Now, let's talk about higher order derivatives. So far, we have been taking the first derivative of a function. The first derivative tells us the slope of the tangent line, but we can actually take the derivative again. When we take the derivative of the derivative, we get what is called the second derivative. There are a few ways to write the second derivative. One common notation is f double prime of x. This means we take the derivative twice. Another notation is this. Both of these notations represent the second derivative. Now, let's talk about a common application. Suppose the position of an object is given by s of t, where t represents time. The first derivative of position gives us velocity. The notation for velocity is v of t. And v of t is the derivative of the position, which is s prime of t. Velocity tells us how fast the position is changing. Now, if we take the derivative again, we get the second derivative. The second derivative of the position gives us acceleration. So acceleration is v prime, which is s double prime. Acceleration tells us how fast the velocity is changing. So you can think of it like this. Position tells us where the object is. Velocity tells us how fast the position is changing. Acceleration tells us how fast the velocity is changing. Let's try an example. We're given a function f of x equals x squared minus 2x, and we need to find the second derivative. In order to find the second derivative, we need to have the first derivative. From the previous example, we found that the first derivative of f of x is 2x minus 2. Now we use the first derivative f prime to find the second derivative f double prime. And I'm using the same definition to find the derivative. The second derivative is equal to limit as h approaches 0 of the first derivative at x plus h minus the first derivative at x all over h. We use f prime in this formula because we need to find the second derivative. And remember, second derivative is the derivative of the first derivative. So first, I need to find f prime of x plus h. F prime is 2x minus 2. I will replace x with x plus h. 2 times x plus h is 2x plus 2h. So f prime of x plus h equals 2x plus 2h minus 2. And I will replace f prime of x plus h with 2x plus 2h minus 2. I will replace f prime of x with 2x minus 2. all over h. Now, I need to distribute this negative sign. Negative of 2x minus 2 is negative 2x plus 2. Now, combining like terms, 2x minus 2x is 0, negative 2 plus 2 is 0, and I end up with 2h over h. Now cancel the h. I have limit as h approaches 0 of 2. And limit as h approaches 0 of 2 is 2. So the second derivative of f of x equals 2. Notice that I keep the limit notation the whole time. Do not remove the limit notation until the expression is simplified and we are ready to substitute h equals 0.